Right, so here we have two functions defined as an odd function and an even function. The important thing about it is the fact that the dotted line is symmetrical about the origin, because if you take any point and go on a line straight through it, has a match on the other side, or in fact symmetrical about the y then x-axis. The other one is symmetrical about the y-axis, like that. They intersect at x equals a. Now, it's given that the integral from 0 to a of f of x dx equals 0.75. What that tells us is the area under the dotted line from 0 to a is 0.75. And here it tells us that the area from 0 to a under the solid line is 0.6. So we have to find the integral from 0 to a of f of x minus g of x dx. Well, maybe we can separate the integrals like that. And now we have a match. The f of x, exactly the same integral, and the g of x, exactly the same integral. So therefore we have 0.75 minus 0.6 giving us 0.15. Oh, here's the next one already. F of x plus g of x, but notice it's from negative a to 0. So let's separate it first. Now let's have a look at this f of x one. From negative a to 0. Negative a to 0 matches exactly 0 to a, with one exception is that f is below the x-axis. So therefore this area from 0 to negative a, or negative a to 0, is exactly the same size as the one there, but being below the x-axis, it's negative. So therefore this one's going to end up with an answer of negative 0.75. This one here, g of x, negative a to 0, due to the symmetry about the y-axis, is exactly the same as this area here. Therefore, this is going to be 0.6, giving us our negative 0.15. This one here, the first thing I'm going to do is separate it. Now notice from negative a to a, so it's sort of combining these two. So let's have a look at it. Negative a to a of f of x, so from there to there, f of x, the dotted line, oh, well, they're going to cancel one another out. A negative value and positive, same value, but positive as opposed to negative. So from the negative to the positive, this is going to be 0. This is going to be 0, this integral. This one here, negative a to a, well, have a look. Negative a to 0 is a duplicate area-wise of 0 to a. So therefore, I'm going to double this area. So it's going to be 1, 2. There we are. 2 times 0 plus 3 times 1, 2. There we are. Run out of space there. Whoops. Next one. Integral from negative a to a of f of the absolute value of x dx. Now, the only way to do that, remember, is to go back to the definition of absolute value. And absolute value says absolute value of x is x when x is greater than or equal to 0, and negative x when x is less than 0. So negative a to a. So therefore, we're going to separate negative a to 0, and we're going to have to change the sign because x is negative. Therefore, negative a to 0, and instead of the absolute value, I'll write negative x because x is negative. So therefore, the absolute value of a negative value, we change its sign. And plus, and then from 0 to a is absolutely just the same, f of x. There it is there. Now, this here, f of negative x and f of x. F of negative x is just this graph, this dotted line graph swung across to the other side to go this side. So it's actually a duplicate. It's f of x swung across. symmetrical about the y-axis. So therefore, we're going to take this area under the dotted and we're going to double it. It's on top, so therefore it's positive still. So therefore, twice that from 0 to a, twice 0.75, giving us our 1,5. Right, so here we have the functions. Absolute value of x minus 2 minus 1 and minus 3 times absolute value of x plus p plus q. There it is there. Determine the value of p and q. Well, that is what we call the vertex point, the maximum value of this absolute value graph. And if you look at the way this is written, this is the same form as the square constant form for a quadratic or a parabola, where if this was brackets squared plus q, then the maximum or minimum would be q when x equals minus p. So exactly the same thing's going to work here. It's the same formula. That means that we know that the vertex, the vertex point is PQ. X minus P is PQ, like that. So vertex point is 4, 9. So therefore it's going to be X minus 4 plus 9. There I've written the actual equation of that graph without even looking at this really, other than the minus 3. And that being the case, I can now see P is minus 4, Q is 9. Use the graphs or otherwise to solve that equation. Now, it'd be mad to do it otherwise, because that's going to be a whole lot more work. But the first thing I'm going to try to do is establish one of the graphs on the left and hope. I'm either going to establish absolute value x minus 2 minus 1 and chuck everything else across to the right. Well, there's the absolute value of x minus 2. I can grab a minus 1 and then shove the rest across there. And hope like heck that we end up with this graph on the other side. So let's take that there. And I'm going to, so right, x minus 2 minus 1. I've just straight written that equation. Minus 3 x minus 4 on that side, and to balance out to give us the 10, I have to have plus 9 here with that minus 1. That is exactly the same as that graph. That is exactly the same as that graph. Phew. So therefore now it boils down to the one above the other. So it means f of x, where's f of x above g of x? Well, that's where they are. That is the case. F of x is above g of x there, and f of x is above g of x there. So now all we have to do is describe these areas. Notice the little exclusion points, because it's greater than not or equal. It's not or equal to. So therefore x it's to the left of 1. So therefore x is less than 1, to the right of 6. Therefore x is greater than 6. So we've taken out all the explanations, and now we can fit another question. Determine the absolute value for 1 to 7 of g of x dx. For 1 to 7 of g of x dx. Well, there to there, it's this triangle. And if you have a look, think about it, it's actually that area there doubled, or this area doubled. In the memo of the IB, they found the integral of the incorrect graph. They've in fact gone and worked with the f of x. So they must have picked it up during the marking phase. So By symmetry, 1 to 7, the integral from 1 to 7 g of x dx equals twice the integral from 1 to 4 of that graph. The areas are the same, that's why. So therefore, we are finding twice the areas from 1 to 4 of integral of 3x plus 3 dx. That's just that one simplified, 3x minus 3 dx. So integrate. The 3 comes out, notice 3, so we have the 6 outside, so we're left with x minus 1, and that's x squared over 2 minus x. Substitute in, and the answer is 27.